Introduction to Programming in Bioinformatics.
Bioinformatics blends biology, computer science, and mathematics to analyze biological data. Programming is at the heart of this rapidly evolving field. Learning the right languages not only boosts your job prospects, but also enables you to handle vast datasets, automate tasks, and contribute to breakthroughs in health technology. Let's explore the most essential programming languages every bioinformatician should know.
Python, a versatile powerhouse.
The Python stands out as the most widely used language in bioinformatics. Its clear syntax, extensive libraries, and active community make it ideal for tasks like data analysis, visualization, and automation. Libraries such as BioPython, Pandas, and SciPy streamline everything from DNA sequence manipulation to advanced statistical modeling. Python's versatility ensures it's a must-have skill in any bioinformatics toolkit.
R, statistical strength and data visualization.
R is another cornerstone in bioinformatics, especially for statistical analysis and data visualization. Used extensively in genomics and clinical data analysis, R offers specialized packages like Bioconductor for processing large-scale biological datasets. Mastering R enables you to perform complex statistical testing, create publication quality plots, and uncover insights from complex biological data.
SQL, managing and exploring biological data.
SQL skills are essential for managing the massive biological databases at the core of bioinformatics research. SQL enables you to efficiently search, filter, and aggregate genomic or clinical data stored in relational databases. Understanding SQL empowers you to retrieve meaningful results from multi-gigabyte datasets and collaborate effectively with data engineers and other technical teams.
C and C++, speed and computational efficiency.
For projects demanding high performance and computational speed, C and C++ are vital. Many core bioinformatics tools and algorithms, such as those for sequence alignment or structural biology, are implemented in these languages. Knowing C or C++ allows you to work on optimizing code, contribute to open-source projects, or interface Python and R scripts with powerful compiled software.
Choosing and learning your first language.
Wondering where to start? Python is ideal for beginners and widely applicable across bioinformatics roles. R is vital for those focusing on statistics and genomics. As you advance, adding SQL for database handling and C or C++ for optimization will broaden your opportunities. The more languages you learn, the more versatile and effective you'll become in the field of bioinformatics.